have over here is I'm going to have a pump, okay? And I'm going to be able to tell the pressure. Pump up the air above the water, and then when it gets to a certain pressure, it's going to push out the little stopper in the bottom, and your rocket's going to fly. So we can go away from it, and we can measure the angle. So let's say we're over here, right? Okay, and what we're going to do is we're going to measure, so this is the bottle when it gets to the top, and we're going to measure this angle here.
With a compass.
With a compass. Or we could probably use a protractor. And how do you think we could work out this height here from knowing the angle? What else do we need to know?
Sound rough.
Oh, yep.
The distance.
Okay, so we need to know a distance.
From the launch site.
Right, very good. So we need to know a distance, which is from here to here. And what if that person looks along the top of here, right? At the bottle. Then, because of gravity, we have this line that will always point to straight down. And so we can work out from there that it would be 40 degrees, right?
Ah, yes.
We use kind of the same technique to work out the distance to the sun. And the transit of Venus, which is where on the 6th of June, where Venus is going to come in between us and the sun and partially block the sun, how do you think we could use that to measure the distance to the sun? I think you guys know. Does anybody else think it's the same idea?
Monkey.
So let's say I'll draw it here. Let's say we have the Earth here, and we have Venus.
And then we have that's Venus, not the sun. And then we have that's the sun. That's
and we have the sun.
That's Venus.
So how? Yeah, there we go. I'm not really good at spelling, am I?
You're a scientist.
I'm a scientist. That's all good. So how do you think we could work out the distance to the sun?
I can't remember what it's called, but I saw it.
Well, I want you to put your thumb in front of you, okay? And I want you to close one eye, and you want look at an object, cover up an object with your eye, okay? Put your hand out and cover up something on the wall or something that you can see with your thumb. So block something out. Maybe I've got a pamphlet over there. I'm blocking out a pamphlet. Okay. With one eye. Okay. Has everyone got something? Okay. Now look through the other eye. Can you see it? Yeah. So that's called parallax. So that is what it means. Is you look at an object. You look at an object from a different angle, and you can work out from that and from the angle. You can work out the distance to an object. So what we did during the 1800s, I think, and Captain Cook, who found New Zealand, did this, is he went to Hawaii on one side of the earth, and we had people up in England, and we had people on the equator, and we all measured when they saw the transit of Venus. And these guys measured this here. And from this measurement here of all the different angles, we could work out the distance to the sun.
My name is Jamie Norris. This is my rocket. I have made it a bit like a missile. It's not 2 litres like it's supposed to, it's 1.25 litres. That's okay because it's going to have more pressure and more lift. And if I hadn't sellotaped down these pockets here, I would get air escaping into here and it might fall off. So I stuck it down so it won't fall off, and the fins are partly for decoration and partly for actually not spinning around because of this.
My name is Christina Brand, and I chose this design because the materials were there. I used a plastic bag for the parachute.
A rocket with 3 fins because I think it will create less drag, and they didn't seal up the pockets because I don't believe it'll fall off. I believe when it comes down, this will act as sort of a dense parachute.